video we're going to have a look at integration by substitution, but in a context that uses a trig expression in the substitution. So we'll do it in the context of a question. It says use the substitution x equals tan theta to evaluate the integral between root 3 and 0 of 1 over 1 plus x squared. So in our previous video where we introduced integration by substitution, the first thing we did was to decide on the substitution, then differentiate it. Well, the substitution's already been decided for us here, so now we need to differentiate it. But notice, it's in the form x equals rather than theta equals. So rather than finding d theta by dx, because it says x equals, we're going to find dx by d theta. So dx by d theta, and hopefully you know the differential of tan theta with respect to theta, but if not, you can check your formula sheet. It's sec squared theta. Then we know we're going to have to change this into a d theta integral later, so make it say dx equals, implies dx equals sec squared theta d theta. Then actually do the substitution. Let's rewrite the integral out. So we've got the integral between root 3 and 0 of 1 over 1 plus, and instead of x, we're going to write tan theta. So 1 plus tan squared theta dx. And now when we change to d theta, we're going to have to change the limits as well. So these are limits that are all to do with x values. We need to make the limits relate to theta values. So if the x equals root 3, that means that tan theta equals root 3. So we get theta equals, and the calculator, so the arctan of root 3, which is equal to a third pi, so equal to pi over 3. We've also got tan theta equals 0, which means that theta equals, so I'm thinking it's 0, but just to confirm, yes it is. So theta equals 0. So equals the integral, and now we've got the new limits between pi over 3 and 0 of 1 over 1 plus tan squared theta, and we're replacing the dx here with what we found dx to be here, which was sec squared theta d theta. So it looks a bit messy. However, this is the point where in all of these examples a bit of magic happens when you remember your trig identities. So let's write the trig identity down for tan and sec. So I always start off by writing the one that we should all remember. Sine squared theta plus cos squared theta is identical to 1. Then I know that if I divide everything here by cos squared theta, then on the right hand side here I will get sec squared theta. So I've divided everything by cos squared theta. So that makes that sec squared theta, that becomes 1, and that becomes tan squared theta. And notice this here, very useful trig identity, because tan squared theta plus 1 equals sec squared theta. So that's equal to the integral between pi over 3 and 0 of 1 over sec squared theta times sec squared theta d theta. Sec squared theta divided by sec squared theta is just 1. So we've got this much simplified integral, the integral of 1 d theta, which is equal to theta. Let's not forget to write the limits in, so that's pi over 3 and 0. Pi over 3 and 0 equals pi over 3, take 0 equals pi over 3. It's important you write the take 0. There are marks to be lost in an exam if you don't sub both limits in. So now let's check the answer on the calculator just to make sure we've got it right. So a little bit of a hack to checking this. So the integral, and let's put the original question between root 3 and 0 of 1 over 1 plus x squared dx, and we get the third pi. Brilliant. So we know we're right. So let's try a slightly more complicated example now from an exam paper. So there it is there. So it says use the substitution x equals sine theta to find the exact value of that. So the first thing we'll do, well, we've already been given the substitution, so let's differentiate it. So dx by d theta simply equals cos theta. And make that say dx equals, which means that dx equals cos theta d theta. Okay, so now we've got the integral between a half and 0, substituting that in, of 1 minus, and our substitution was x equals sine theta, so sine squared theta to the power of 3 over 2 dx. And we're about to change the dx to d theta now. We're about to replace dx with something to do with d theta, so we need to change the limits also to theta limits. So if we've got x equals a half, that implies that sine theta equals 1/2, which means that theta equals, let's put in the calculator, so arc sine of 1/2, which is a 6th pi. So if x equals 0, that means that sine theta equals 0, and we know that that just means theta equals 0. So now we know that the integral is between theta limits pi over 6 and 0. And we've got 1 over 1 minus sine squared theta to the 3 over 2. And instead of dx, we're going to write cos theta d theta, as we rearranged earlier. So equals the integral between pi over 6 and 0. And you've just got to notice that 1 minus sine squared theta, as in the previous example, knowing your trig identities massively helps. You've got to notice that 1 minus sine squared theta is equal to cos squared theta. So that becomes 1 over cos squared theta to the power of 3 over 2 times cos theta d theta. Now let's keep on doing this. Equals the integral between pi over 6 and 0 of 1 over, well, multiplying the indices together, as is the rule for these nested brackets, 3 over 2 times 2 is 3. So cos cubed theta times cos theta d theta equals the integral between pi over 6 and 0 of 1 over cos squared theta d theta. So what you've got to notice here, it's not readily integrable, is 1 over cos squared theta. But if we rewrite it, if we rewrite 1 over cos squared theta as sec squared theta, then it is something that we know the integral of. So the integral between pi over 6 and 0 of sec squared theta d theta. And you can check this in your formula book, but you should know the integral of sec squared theta by now. It's tan theta. So equals tan theta between pi over 6 and 0 equals tan of pi over 6, take tan of 0, so tan of pi over 6 is root 3 over 3. Take 0, which is just root 3 over 3. So let's check the answer in the calculator now. Let's put exactly what we're asked to integrate in there. So the integral of 1 over 1 minus x squared, the power of 3 over 2, between 0 as the lower limit and a half as the upper limit, which is equal to that there. So we need to be able to find out whether that's equal to root 3 over 3. Well, if I take root 3 over 3 and get an answer 0, I know that I'm right. Take root 3 over 3 equals 0. Yeah, so we've got the right answer to that. So that's, in an exam, I would recommend doing that to give you some comfort that you've got the right answer. So that's it, integration by substitution, but with more complicated trig substitutions. For more videos like this, subscribe to our YouTube channel, and to find out more about our Skype tuition and revision courses, go to alevelmathsrevision.com.